All right, guys, today we're going to talk about absolute value functions, and particularly we're going to look at the graphs of absolute value functions. So an absolute value function is written as y equals absolute value of x, or you may write it as f of x equals absolute value of x. So right here you can write it as y equals, like we have before, or f of x equals absolute value of x. The reason I wrote it with f of x is because it says function, and usually we use f of x or g of x to represent function notation. All right, I want to look at a little bit more detailed equation. So those are your parent functions, or the most basic absolute value function, where it just is the absolute value of x. But over on the left here where it says absolute value functions, here is an equation that you need to be familiar with as well. So where it says f of x equals a times the absolute value of h plus k, and this is going to be the absolute value function that we're going to use more often. So here's the form that you need to know. And you need to know that h and k is the vertex. So go ahead and write that down. I'm going to highlight that here for you so that you know that that is important. All right, now every absolute value function is going to be a V-shaped graph. So you need to know that it's a V-shaped graph, and the turning point is called the vertex. All right, so we're going to look and see what does that look like on your graph here. So complete the table to graph the function, give the domain and the range. So if we have, this says x, this is like your f of x. So that's your x equals absolute value of x. So we get to choose our x as our independent number. So we get to pick our x's, and then we plug it in here to see what the y value is. So if we do -3 as x, absolute value of -3 is +3. Remember, absolute value is distance from 0 on a number line. This would be 2, 1, 0. Absolute value of +1 is still 1. Absolute value of 2 and 3 are still those numbers. So that is just the distance from 0. So what does these look like on the graph? So I'm going to graph these as ordered pairs. -3, +3, -2, 2, -1, 1, 0, 0, +1, 1, 2, 2, 3, 3. So you can see you get that V-shaped graph right here. All right, if I continue to put points in both directions, this would be a continuous graph. So we have to draw arrows to represent that the absolute value does continue. All right, so our domain is our x values. So basically, what does the graph do going both left and right? Well, it is a solid line going in both directions, so that's going to be all real numbers. I better write that out because you'll see it written out later. There is a little shortcut that I use sometimes. If you see this symbol right here, that means all real numbers. It's hard to put that into Canvas, so you won't be able to type that number, I would say, in Canvas, but you will be able to type in all real numbers. All right, the range is your y's. If you look, the range is everything above the x-axis. Well, and that would be 0. So your range is your y's, so it's all y's greater than or equal to 0. All right, pause the video if you need to. Make sure you get all your notes taken, and then we're going to move on. All right, here's the steps in order to graph this equation using a table. All right, to create a table of values, it's best to place the vertex in the middle. That's important. The vertex is the turning point. Remember, it's a V-shaped graph, so you want to place the vertex in the middle of the table and then include values on both sides. Okay, so you want numbers on both sides of the vertex. Find the x value for the vertex. Okay, we're going to do that using the equation above. Set the expression from the inside of the absolute value equal to 0 and solve. Place the value in the middle row of your table, number up and down, then complete the table. Okay, and then we will graph. All right, so let's look at a couple examples here. All right, so number 4 says that the absolute, or f of x equals absolute value of x minus 4. Remember the equation above that I wrote down. So f of x equals, this should be in your notes, a times absolute value x minus h plus k. All right, so what is this? Well, a is going to tell you if it turns up or down. It's always also going to tell you if it gets wider or more narrow. So that's what A does. H and K are your vertex. So remember that this is minus H plus K. So your vertex is always going to be the opposite of whatever the sign is here, because a negative would be a plus, and since this has a minus, that would work that way, sort of like slope and some other formulas that we use. All right, so inside the table here, it looks like our vertex is H, would be positive 4. So we're going to come down here in the middle of our table. We're going to put positive 4. And then we're going to number on both sides of that, because this is our vertex. So if I number on both sides, I'm going to have 3, 2, 1. And then I'm going to have 5, 6, 7. Then I'm going to plug those numbers into the equation to solve for y. Remember, this is my independent. I get to choose these, and then I plug them in to find f of x, or my y. So 1 minus 4 is negative 3. The absolute value of negative 3 is 3. Plug 2 in, I get negative 2. Absolute value of negative 2 is 2. Take 3 minus 4, I get negative 1. Absolute value of that is 1. 4 minus 4 is 0. And 5 minus 4 is 1. Absolute value is still 1. 6 minus 4 is 2. Absolute value is still 2. 7 minus 4 is 3. Absolute value is still 3. All right, so very quickly, hopefully you can find the vertex and fill in your table. Now you need to graph it. So if I go over 1, up 1, 2, 3, that's going to graph my first point. Go over 1, 2, up 1, 2. And I'm going to go over 3, up 1. I'm going to go over 4 and stay on 0. And over 5, up 1. 6, 2, and 7, 3. And that makes our V-shaped graph. If you're graphing these correctly, all absolute values should be a V-shaped graph. It goes left and right, or my domain is all real numbers again. And if I look at my range, it's all my y's above 0. So it's going to be y greater than or equal to 0. All right, number 2 is just a little bit different. It has a number in front of x. So you have to divide the 6 by 2 to get that number. Okay, so it's going to be 6 divided by 2. Again, the sign is going to be the opposite of what's in there inside your absolute value, because the equation is always opposite h. So it's going to be negative 3. I put this in the middle of my table. I go backwards and I go forwards. That way it creates my V. If you don't have the vertex in the middle, if you choose points all on one side, you're just going to get a line. You're not going to get that V shape. So you have to have the vertex in the center in order to get the V-shaped graph or to graph it correctly. All right, so -6 times 2 is -12. 12 plus 6 is -6. Absolute value of that is 6. -10 plus 6 is -4. Absolute value is 4. 8. -8 plus 6 is -2. Absolute value. 3 gives me -6 plus 6, 0. And then -2 would be -4. That would be 2. Absolute value is still 2. 2 plus 6 is 4. Or sorry, -2 plus 6 is +4. Absolute value. 0 times 2 is 0 plus 6 is 6. So all I'm doing is taking my x's, plugging them into this equation to find my y. Then I'm going to graph it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. -6 up 6 over 5 up 4 over 4 up 2 over 3, 0, and then -2, -1, 4, and 0, 6. So again, we get that V-shaped graph. The vertex is just shifted to a new location. And you can see the steepness of this. It's a little bit more narrow graph because the 2 here changes the how wide or narrow the graph is. All right, domain again, all reals. And the range is going to be all y's greater than or equal to 0 again. All right, pause this if you need to. We're going to move on. All right, looking at the next example, f of x equals absolute value of x plus 5. As you can see, h, there is no h. There's nothing inside of here. So your vertex, this time will start at 0. Okay, so your vertex is the center or the turning point for your absolute value. The h moves you left or right. The k moves you up or down. So looking at this one's probably going to be moved up 5. All right, so we need to go on each side of 0. So let's go back, -1, -2, -3, and then I go 1, 2, 3. Plug these numbers in. Absolute value of -3 is 3. 3 plus 5 is 8. -2 becomes 2 plus 5. -1, so 1 plus 5. 0 plus 5. And then 1 is 1. 1 plus 5 is 6. 2 plus 5 is 7. 3 plus 5 is 8. So to graph that, I'm going to go 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. -2. -1, 6. And 0, 5. 1, 2, 3, 4, 5. 1, 6, 2, 7, 3, 8. So as you can see, the vertex did not move away from the origin. It just moved straight up 5. Okay, so that is your absolute value. Again, it goes left and right both ways, so it's going to be all reals for your domain. And your range is going to be everything above the lowest point or the vertex, which is 1, 2, 3, 4, 5. So all y is greater than or equal to 5.